Well, hello there, and welcome to this mathematics tutorial class presented to you by O3 Schools JAMB app. Well, in this class, we shall be looking at permutation and combination. However, before we begin, there are various things you need to know. First of all, you need to get your O3 Schools JAMB app. Now, this app will help you greatly as you prepare for your JAMB examination. It has so many features that are well designed for students preparing to take JAMB. First of all, it has your past questions, so there will be no longer any need to get your physical past questions because you have it on a mobile device which you can use at any time, anywhere. Then also it has a CBT base, which basically means you can actually practice your computer-based tests. You can practice how your JAMB will appear on that day using your O3 Schools JAMB app. So if you can practice as many times as possible, on that day, it will no longer be strange. So you know what all the features are, what all the purposes are, what to press and what not to press. And also, your O3 Schools JAMB app actually has a way to make this exam easier for you, which is that as you prepare, you can arrange it to suit your needs as at that moment. If you're just starting, you could increase the time while training yourself. Towards the end, you could actually even begin to reduce the time to train yourself to work faster than the time being allocated on that day. Also, you can alter the number of questions and you could even select the topic you want to answer. You could choose to remove certain topics, choose to solve just for one particular topic. So you could choose, like I have on the board now, you could simply go to mathematics within the mock exam mode and choose the topic permutation and combinations. What they'll do then is that the app then brings out questions related only to this topic for you to answer. You see, it's very flexible and you can adjust it as needed. Furthermore, within this app, even after answering questions, within your corrections, you shall try to see a breakdown of how you performed in each topic to help you further so you know which topics you are weak in and which you are trying quite good in. It even gives you a breakdown of the time. So you know, okay, I'm spending too much time on mathematics, I'm spending adequate time on economics, or whatever. So, as a student, you really need the O3 Schools JAMB app because it will help you greatly. Now, this app is not free. You can download it for free and install, of course, but however, you have to activate this app before you can enjoy proper functionality. And the activation fee simply costs the sum of 2,500 naira only. 2,500 naira for your activation key. Now, there are several methods to pay, and they are all included in the app. So, we go through the app, pick whatever payment method is preferable by you, pay, and your app will be activated 100% guarantee. So, it's truly very simple. Get your O3 Schools JAMB app, and I'll show you towards the end. And after you see the results of your JAMB, you'll be one of those who will come back to give testimony as to how the app has helped you get the best score you possibly could. And now, without any further ado, let's look at this topic, permutation and combination. Now, please note, despite the fact that there's an and in the middle, it's actually one topic. However, there is a slight difference between the two terms, to permute and to combine. What are we doing? What's the difference? They both actually have to do with the ways in which you can scatter something, different orders of arrangements and different ways you can scatter and mix them up. But the key difference is that in permutation, the order is important, but in combination, the order is not important. What do I mean? If I want to select 4 students out of a class of 20 to go play football, the order in which I pick these students is not important. If I also pick a student named John first to go play football, or I pick him as the last person, does it matter? No, he's still going to be one of the 4. On the other hand, in permutation, the order matters. If I'm giving out money, reward based on positions, the person I then call first and then the person I call second going to get different amounts of money. In that situation, the order becomes important. So please note that in this topic, they will never ever tell you using permutation solve this or using combination solve this. When you read a question, you have to interpret it by yourself. In this particular question, does the order matter? If the order does not matter, you are using combination. While if the order matters, then you have to use permutation. Now, I've been saying you will use and you will use, but however, how do you use? Well, first key thing we learn in this topic is a concept known as factorial. Now, the factorial of any number, say, which is symbolized by n factorial, this exclamation mark in mathematics we call it factorial, is simply given by n times n minus 1 times n minus 2 times n minus 3 all the way down till you finally get to 1 times 0 factorial. And please note that 0 factorial equals 1. So very, very straightforward. This means that say you're looking for 5 factorial, that would be 5 times 4 times 3 times 2 times 1, which should give you 120. So that is the concept of the factorial. So that's the first thing you need to know. And once you know factorial, you can then know the difference between permutation and combination. So these are then the two different ones. Now please note, n permutation arrow is simply written as n factorial over n minus arrow factorial. The n permutation arrow is n factorial divided by n minus arrow factorial. While on the other hand, n combination arrow is written as n factorial over n minus arrow factorial, then another additional arrow factorial. And that is the underlying difference between the two. This extra arrow factorial there. Meaning that n combination arrow, which at times is rewritten as n with the arrow down here, is the same thing as saying n permutation arrow divided by arrow factorial. So the idea is simple. Permutation, combination. These are our different concepts. So depending on your question, you then decide which you are using and how to proceed. However, when you are using them, what do n and r stand for? Now, n is your total number of options, while r is the required number. So say I'm picking 5 students from a class of 20. The 5 students are those I require. That means my r equals 5. And the total number of students in the class is 20. That means my n equals 20. Now, with this basic knowledge, you're actually ready to solve some questions. However, what you must now learn about permutation and combination is that they have some particular special type of questions. So we'll endeavor to cover the various ways permutation and combination can come out within the questions we are going to solve from our O3 schools JAMB app. But please note, like I said, permutation and combination, the questions come out in different ways, and almost to each different method, you have to apply a different way of solving. So analysis comes, you see a question, you know what the question looks like, and what method you use when you see something that looks like that. Okay, let me get my O3 Schools JAMB app open on my phone here, and let's see. Our first question from the year 2000, and this is question number 43. Now it says, in how many ways can the word mathematics be arranged? How many ways can the word mathematics, the subject which we are studying? Now, if I ever ask in how many ways can something like this be arranged, the first step is always count the number of things you are arranging. So number of ways becomes, how many things am I arranging? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That means 11 of them. That's 11 factorial all over what else? Well then, Are any of these things identical? If they're identical, then I'll have to do something else. I check out m and m are identical. If I'm arranging m and m, since they are the same, I have to divide by 2 factorial. Is any other thing identical? Yes. A and A. Another 2 factorial. Then C and C. Another 2 factorial. And there's nothing else identical. So when I check out my options, I can see that this is option C. Now please note that this could have been solved further to get an actual number. But the number is so big and JAMB knows the kind of calculator they gave to you. So that's why I prefer to just leave it like this. If you have a scientific calculator, you can simply press this number into your calculator and you get your answer. The number is very, very large. So for this question, this is all. This is our final answer. So I'll repeat one more time for emphasis. If you are arranging the letters in a word or different digits of a number, and you're arranging all of them, all you simply do becomes the total number of things you're arranging, factorial, divided by any ones that are identical. Take their number and put their factorial as the denominator. That is all. Okay, let's take another one. This one is from the year 2005, question number 47. 2005, question 47. And this one says, in how many ways can 6 colored chalks be arranged if 2 are of the same color? We have 6 colored chalks we want to arrange, but 2 are of the same color. And that should take your mind back to something like this. I have 6 things, let me just write them like this. 1, 2, 3, 4, 5, and 6. However, 2 of them are of the same color, which means just like in question 1 and above, my number of ways becomes, how many things do I have? 6 factorial over, are any of them identical? Yes, 2 of them. That becomes 2 factorial. But if you notice, in these particular options, my answers are actual numbers, which means I can't just stop here. I have to express my factorial. 6 factorial becomes 6 times 5 times 4 times 3 times 2 times 1. All over 2 factorial, which is 2 times 1. So this 2 times 1 takes care of this 2 times 1. Now I'm left with 6 times 5, 30. 30 times 4, 120. And times 3, 360 ways. And that is option D. So you see, very, very easy. As long as you can identify the nature of the question, you can identify the method being applied there, you can get your answer. All right. My next question, this time from the year 2009, question number 48. For this one, I'm being asked, in how many ways can 9 people be seated if 3 chairs are available? How many ways can 9 people be seated if 3 chairs are available? That tells you now that I have a total number and I have a number I require. Because if I have 9 people total and there are just 3 chairs, that implies that just 3 of them may sit down. So in how many ways can I do this? The next thing you then ask yourself is this to be permutation or combination? How do we know? Does the order matter? If I sit down, let's say we are sitting 3 people down and their names are, let's just say, John, James, and Jude. Now, this is one way they could sit down, John first, then James and Jude. On the other hand, I could also still have John, then Jude, then James. Isn't that a different order? Yes. And does this matter? Yes, because that's a different sitting order, which implies that in this case, I'm actually looking at permutation because the order in which they sit actually matters because that would then be a different arrangement. You see? So accordingly, that will mean that my number of ways must be n permutation R. N is 9, permutation 3. And following the formula which we noted down for permutation, this will give me 9 factorial all over 9 minus 3 factorial. Now this will be 9 factorial over 9 minus 3 is 6 factorial. And please take note, the mathematical equivalent of just dividing both sides by 3 doesn't apply in factorial's case. Just like if you have sine 60 over sine 30, you won't just say 30 into 62. No, you have to expand first. And we have a simple way of expanding. What do I mean? We'll expand this numerator until we get to the top. We'll expand this numerator, until we get to the denominator, rather than expanding it completely. Because this will give me 9 times 8 times 7. Instead of going to 6, 5, 4, 3, 2, 1, I just stop this and say 6 factorial. Because I know that 6 factorial will still be 6 times 5 times 4 all the way to the end. You may ask, why did I do that? Because I know that if I stop it here, I have 6 factorial here, and now 6 factorial can actually cancel 6 factorial. So if you go through the long journey, you still get the same answer. But this is much faster. So I'm now left with simply 9 times 8 times 7. And if I get my calculator open, I can find out my answer. 9 times 8 times 7 is 504. Meaning there are 504 ways of this arrangement, and that is option B. So I hope we can see. Simply answer your question, is it permutation or combination, and then solve accordingly. Okay. Next up, we go to the year 2009 and look at question 47. This one says, in how many ways can a delegation of 3 be chosen from 5 men and 3 women? Let's see. We have 5 men and 3 women. We want a delegation of 3. If at least 1 man and 1 woman must be included. Now, this is what is referred to as conditions. I'm being given a question. Rather than just solve, I have a condition which I must uphold. And what does that mean? I have 5 men and 3 women, but I want to choose 3 people out of them. Now, as you are aware, if I'm choosing 3 people to form a committee, doesn't matter who joins the committee first. Maybe the first member, maybe the third member, but I'm still in that committee. And for that reason, I know that this has to be combination. However, I can't just solve this combination and say I'm done, because now I have a condition. What's the condition? There must be at least 1 man and at least 1 woman. Meaning this committee cannot just be entirely men, and it also cannot just be entirely women. That means if I was to start with 1 man, if the committee has 1 man, it must have 1 man and 2 women. So this is the only way to complete it to 3, which is what they told us they wanted. So I'm going to just use short for the women and use W instead. And for and, I'll use the common symbol for and. So 1 man and 2 women. That's 3 members of the committee. Or I could have 2 men and 1 woman. Also 3 members. So you see, as long as we say there must be a man and a woman, these are the 2 possible ways I could arrange this committee. However, how then can I start? Keep in mind, 3, 3. That's what makes it know we are correct, because we still have 3 members. So that means in the first case, number of ways, out of 5 men, I want to choose 1 man. And because the order does not matter, it's combination. The number of men total is 5, but I require just 1. So that becomes 5 combination 1 Then here is where you have to remember in mathematics, like you was representing probability and is generally taken as times. So 5 men and times 2 women. Out of 3 women, I want to choose 2. 3 combination 2. And also, as you know, all is plus. Then, out of 5 men now, I want 2 men. So that is 5 combination 2 times. Then out of the 3 women, I want to choose just 1 in this new group. And these are the 2 possible arrangements. So let's just get the final answers out. 5 combination 1 simply means, from the formula as we noted in the beginning of this class, 5 factorial over 5 minus 1 factorial, 1 factorial, times 3 combination 2 is 3 factorial over 3 minus 2 factorial, 2 factorial, or becomes plus 5 combination 2, 5 factorial over 5 minus 2 factorial, 2 factorial, times 3 combination 1, 3 factorial over 3 minus 1 factorial, 1 factorial. Okay, let's just get all the brackets out of the way. This is 5 factorial over 5 minus 1, 4 factorial. And I know that 1 factorial is 1, so I can get rid of that. Times 3 factorial over 3 minus 2 is 1. And I also know 1 factorial is 1. So ignoring that, I have 2 factorial left behind. Plus 5 factorial over 5 minus 2. I know that's 3 factorial. The down here is 2 factorial times 3 factorial over 3 minus 1 is 2 factorial. And 1 factorial is 1, so I ignore that. What can be done next? I begin to get my answers. I'll notice here that 3 factorial can cancel out 3 factorial. So I get rid of that. While this way, 5 factorial can be expanded to give me 5 times 4. But instead of continuing to 3 times 2 times 1, again, I notice there's 4 factorial down here. So if I simply stop at 4 factorial, I have something that can cancel this. Times, here is 3 factorial. If I expand, instead of going to 2 times 1, then I can just stop at 2 factorial. Because there's 2 factorial down here that can cancel it. Plus, here is 5 factorial. This 3 has already cancelled this, so I'm just having 2 and 2 down here. Let me expand this. 5 times 4 times 3 times 2 factorial. Then down here, I will leave 1 2 factorial like this, so I can cancel this while I expand the other one. I hope you understand why. This one is left, so I can cancel this. This other one was expanded because there was nothing to cancel it. 2 here 1 into 4 is 2. This cancels this, and this cancels this. 5 times 3 is 15. And 5 times 2 is 10. 10 times 3 is 30. So 15 plus 30 is 45. And that is my option D. So this committee has 45 ways in which it can be formed. All right, so let's proceed. It's time for our 5th question. I hope we are learning the methods as they go with different types of questions. That's part of what makes this topic a little bit special. You don't just memorize the formula and use it for every single question. The formula varies, the method varies, depending on the nature of the question. For example, this next one from the year 2007, question 9, this one says, in how many ways can 6 subjects be selected from 10 subjects for an examination? Now, imagine you are in a class and you have 10 subjects in your class total, but you have to choose 6 out of these 10. Now, does it matter which one of those 6 you choose first when it's time for exam? No. You're going to write all those 6 irrespective of if you choose one first or the other, which means that quite simply, I must be applying combination in this question. You see the logic you have to always put in. Ask yourself, does it matter which one comes first? No. Assuming I choose maths first out of all my options, does that change the nature of my exam? No. Just means that maths is among. Which means I want to choose 6 as the number I require out of 10 as my total number. And as such, my number of ways is n combination r, which is 10 combination 6, which from the formula is 10 factorial over 10 minus 6 factorial, 6 factorial. And as we know, 10 minus 6 is 4 factorial, 6 factorial. Now, when I have something like this, what do? I have to expand, obviously, and I'll prefer to stop at the bigger one rather than the smaller one. That means I will have 10 times 9 times 8 times 7, and I stop at 6, which means I will expand the smaller one. 4 factorial is 4 times 3 times 2 times 1. Then I'll leave my 6 factorial as it was. That way, 6 factorial cancels 6 factorial. What else can cancel? 2 times 4 is 8. And 3 into 9 is 3. So I'm left with 10 times 3 times 7, which as we know is simply 210. There are 210 different ways I have to select 6 subjects out of 10. And that is option D. They say, reason out your logic and proceed with your solving. That is the method we always apply. Okay, so our next question is from the same year, 2007, but this time, question number 4. I think this is our 6th question. Now, for this one, we are told that a senatorial candidate had plans to visit 7 cities prior to a primary election. However, I could only visit 4 of the cities. How many different itineraries could be considered? Okay, now here's the deal. This man plans to visit 7, but could only visit 4 at the end of the day. How many ways could this be considered? Ask yourself, does the order matter? That's always the trick. And you notice that in this question, yes, the order does matter. Why does it matter? Because if this man had gone to the let's just it out and see. So we have cities A, B, C, D, E, F, G. These are 7. Now, if I want to visit 4, I want to visit these. If I have gone to this one first, it matters to this one because that means I can no longer miss it. Because it means that, let's say I go to you first, second, third, and then you fourth. Those 4 posts suddenly become important because I would have gone to this one 5th, but time would not permit me. Which means again that the order is now what? Important. You get the logic here? This man could only go to 4 of them before time ran out, which means that the one which comes first and which comes second is suddenly important in my planning and in everything. I have to know which one is going first and which one is going second. And as a result, when the order is important, we know we are dealing with permutation. So, the total number of cities you could have visited was 7, but you could only go to a required number of 4. And as such, the number of ways becomes 7 permutation 4. And as you know from the formula for permutation, that is 7 factorial over 7 minus 4 factorial, giving me 7 factorial over 3 factorial. That will be 7 times 6 times 5 times 4 times 3 factorial over 3 factorial. Because we know these will cancel out. And then we'll continue go to our calculator and type in 7 times 6 times 5 times 4, giving me 840 different ways. And when I go back and check my options, I can see that that is option B. So you see, The solving method is very important in your solving. Okay, remember again the logic of the question is what you always have to reason out. Will this be permutation or will this be a combination question? Okay, this time I'm going to the year 2006 to look at question 9. And this one actually is quite straightforward. For what value of n is n plus 1 combination 3 equals to 4 times n combination 3. This is simple arithmetic, no logic required. Apply your formula. Now, if you are feeling particularly lazy, you could simply try a simple method, which is put in the numbers in your options. Try, what if n is 6? This becomes 6 plus 1, 7 combination 3. Then would that be equal to 4 times 6 combination 3? Try that. Then you can just try the options until you see one that works. But however, I'll prefer the proper method of solving. What can we do? For combination, as we are aware, n combination r should give me n factorial over n minus r factorial r factorial. And this right now ought to be equal to 4 times n factorial over n minus, my r is 3 factorial 3 factorial. Okay, so let's see what we can do. This is going to be n plus 1 factorial over 1 minus 3 over here is minus 2. That'll be n minus 2 factorial 3 factorial equals to 4, opening this bracket, n factorial over n minus 3 factorial times 3 factorials. Now, obviously, 3 factorial gets rid of 3 factorial. Then let's see, can we make any of that thing cancel out? Yes, we can. How do we do that? Look up here and tell yourself. Remember, in factorial, we're always subtracting by 1. So if my first element is n plus 1, if I subtract 1 from n plus 1, simply saying n plus 1 minus 1, 1 minus 1 is 0. Meaning I'll be having n plus 1 times n factorial over, next up, my denominator here, remember in factorial we are always subtracting 1. So if I have n minus 2 factorial here, that will give me n minus 2 times, after n minus 2, what should be next? N minus 2 minus 1. And minus 2 minus 1 is minus 3. And this is times n minus 3 factorial. While here will be 4n factorial over n minus 3 factorial. I may be wondering, why am I doing this? The simple reason is because once I look here, I noticed there's n factorial here, and now there's n factorial here, meaning they can cancel out. And in the same way, there was n minus 3 factorial here, and now there's 1 here as well, meaning these can cancel out. And if you notice, all factorial is now gone from my equation, leaving me simply with n plus 1 over n minus 2 equals 4. And from here we do simple arithmetic, cross multiply. N plus 1 times 1 is n plus 1. This becomes 4 times n minus 2. That will be n plus 1 equals to 4n minus 8. And then collect like terms. Let 4n come to the left. N minus 4n equals to minus 8. Plus 1 to the right, minus 1. N minus 4n minus 3n minus 8 minus 1 minus 9 over minus 3 over minus 3. And n must be equal to 3. And that is option D. So you see, very, very easy. If ever you have a question like this with just letters and variables, you have to find the letter. Just apply your permutation and combination formula and see what happens to the expression. Cancel out when you can, and your solving will come out. If you can't, or if you feel like that may be stressful, simply plug in your options in place of those numbers and see which of them would actually give you the same answer on the left and right hand side. Okay, question 48 from 2005. That's our eighth question, I believe. This one says, how many possible ways are there of seating 7 people? And the people are listed as P, Q, R, S, T, U, and V at a circular table. Now, please note, a circular table is a special condition. Why is that? It is because a table has no beginning and no end. How then am I supposed to start my arrangements? Well, the simple method is you're going to fix one person and then decide to start arranging around that person. One more time, if I'm arranging around a circle, the circle has no beginning and no end. If my circle was perfect, it would not. And as a result, you would have no idea where you are starting from or where you are ending. How can you arrange then? The only way to arrange is to tell somebody, you'll be my number one, and everybody will have to then be arranged around this person. And as a result, that means out of the 7 people, I'm not going to arrange just 7 of them. I'm going to remove one person. 7 minus 1 becomes 6. That means I'm going to actually be arranging 6 people around one fixed person. And as a result, my number of ways becomes 6 factorial because I'm arranging just 6 people. And 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. And I believe that gives us 720 ways. When you check your options, that is option B. So please do be very careful. If ever your question requires you to arrange in a circle, always note that in that circle, you're going to subtract 1 from the total number before you start your arrangement. Okay. Now for question number 9, this is from the year 2003, question 48. And I do believe this looks a bit like our example 3, which we solved some time ago. This one is even a little bit simpler than that. This one tells us, find the number of committees of 3. Again, remember, this one, they still want 3 people in committees that can be formed consisting of 2 men and 1 woman from 4 men and 3 women. Now, if you look at this one, it is different from that first question under the simple instruction, which is, in that case, I was told at least 1 man and 1 woman. Now, they are not giving me that choice. They have just told me, I've been instructed, there must be 2 men and 1 woman. And if you remember, in a committee, it's usually combination because it doesn't matter who I choose first into the committee. Therefore, the number of ways becomes, out of 4 men, I'm to choose 2 as for combination 2. And out of 3 women, I'm to choose 1 woman. That's 3 combination 1. Apply the combination formula. That becomes 4 factorial over 4 minus 2 factorial, 2 factorial, times 3 factorial over 3 minus 1 factorial, 1 factorial. Okay, this becomes 4 factorial over 2 factorial, 2 factorial, times 3 factorial over 2 factorial, 2 factorial. Let's do the expansion this way. That becomes 4 times 3 times 2 factorial as usual. We'll keep one of these 2 factorial to cancel this and expand the other. Times 3 times, I also stop at 2 factorial here. So that, sorry, this was 1 factorial, should still be 1. So that can cancel these 2 factorial down here. And I know that 1 factorial is 1. So this is 1 factorial here, now 2. This 1 came down 1. 3 minus 1 is 2. So 2 factorial cancels 2 factorial, factorial, 2 factorial. 2 here 1, 3 into 4 is 2. And I'm left with 2 times 3 times 3. 2 times 3 is 6. And 6 times 3 is 18, which we can see in our options as option D. So you see, these are very, very easy. And it's time for us to take one last question on this topic. One last question on permutation and combination. This is from the year 2002, question 15. This one says, how many 3-digit numbers can be formed from 3-digit numbers can be formed from 3, 2, 5, 6, 4 without any digit being repeated. Now I have 5 different digits and I want to form a 3-digit number. And as you are aware, in numbers, does the order of the digits matter? Absolutely. Having 3, 2, 5 is definitely not the same as having 5, 3, 2, which means the order is important when arranging numbers. So it must be permutation. So my number of ways is, how many digits in total? 5. And how many do I need? Just 3. So 5 factorial over 5 minus 3 factorial. That gives me 5 factorial over 2 factorial. And 5 factorial is 5 times 4 times 3 times 2 factorial. 2 factorial gets rid of 2 factorial. 5 times 4 is 20, and 20 times 3 gives me 60 ways, which is option A. And this brings us to an end of this class on permutation and combination. So we've treated several methods these questions can come out. It's up to you now to go through your O3 Schools JAMB app and find many more questions so that you can see the different ways this question can appear and how to tackle them. And I'll help you out with a few, which you can then go and try on your own. But remember, you can comment your questions, or rather your answers to these questions, beneath this video right here, and we shall definitely respond to you to let you know if you're on the right track or not. And if you are not, we'll endeavor to give you clues and ideas on how best to get to the right answer. So 2006, question 2, and then last but not least 2008, question 48. You can try D6 to make yourself stronger. How about even the 7th one, this time from 2008, question 47. So try these and check your O3 Schools app for many more, and work on them, and you shall try to become quite good at permutation and combination. And as you know, in order to check out these questions on your O3 Schools JAMB app, you will have to activate your app. So please do that, and I wish you success in your examinations. Remember also to subscribe to this channel to see more videos explaining different topics across your different subjects as you prepare for your exam. Thank you very much for watching. My name is Athanasius.